Alright, hello everyone. I'm going to show you how to make a wall jump like this. Like so. And it's for the left and the right wall. And you'll be able to choose. If you found both walls, you'll automatically choose the most nearest wall. So for this tutorial, I'm using these animations, parkour animations by Court Nicole. These are pretty cool, very high quality. So yeah, let's get started. So in here, we will be making some functions. So first, I'm gonna make a get root actor transform, and I'm using the mesh, and we're gonna do get socket transform, and I'm gonna be getting the root. And by the way, the reason why I'm doing this is because I want to make this compatible with the normal rotation handling, and also if you are using the game animation sample, they use rotation a little bit differently. So if you were to try and use the typical nodes for the get right vector, get forward, get up vector for the actor, it wouldn't fit what's visually shown. So that's why I'm going to be using the root bone of the actual character, and you'll see later on what I'm referencing. So here I'm going to break vector, and I'm going to make a vector, and obviously this is going to be really low to the ground since it's the root bone. So we're just going to add 90 to it. And same thing for our rotator. We're going to break rotator and make rotator. Just going to plug these in. And same thing for our rotation. We're going to add 90 to the Z because I believe our root bone would either be facing this way or this way. Alright, I found that on the mannequin, that I needed to rotate it 90 so that it's forward properly. It may not be that for you, so if you ever have problems with the trace being messed up, you could come in here and remove the 90 or do negative 90, whatever would work for your character. So then I'm going to do a return node, and I'm just going to put this in here. This will be our return vector and our return rotator. And I'm going to use we're going to make this function pure. And that's all for this function. So now we can make our trace function. So this will be trace for traversable wall. And in here, we're going to use that function we just made. And we're going to be using sphere traces. So sphere trace by channel. And our return vector will be our start. So basically if our character is here and our root bone's here and we added 90, so it'll be like the typical actor location. So we're going to start here. And then we're going to do a right vector from our character, which will be like this. So that's how we'll be tracing for the walls next to us. So with our rotation, we're going to do right vector. And I'm going to multiply this. So this is how far to the right we're tracing. So I'm going to do 150. And I'm actually going to add another pin here, which will also be a float. And I'm going to create an input on our function, which will be a float. And this will be our direction multiplier. The reason I'm doing this is because I want to be able to multiply this either by 1 or -1, so that I don't have to make separate functions for left and right. I can just change this, and it'll automatically trace to the left or to the right. And this will be default to 1, which will be right, because obviously we're using the right vector. And if this is -1, it's the opposite of right, which is left. So you can either drag this in here, or we can call direction, get direction multiplier, and then plug this in here. And then we need to add this on top of our start. So off of our return vector here, which is our start, we go like this, and this will be our end for the trace. And the radius will be 5. Visibility will be our trace channel, and debug type I'm gonna do for 1 frame. Awesome, so we can move on here. So I'm gonna use a branch, and our condition will be the return value of the trace. And off of false, we're gonna do return node. And we're gonna basically return a Boolean, which will be return value. This will basically just say if we found a traversable wall or not. And we'll be needing these later. We'll be needing a vector and a rotator. So this could just be our wall location and our wall rotation. And since we didn't find a wall, we don't need to put anything here, and this is already false. Next, we'll be needing to break our hit result from our trace. Like so. And we don't need to do anything here right now, but we are going to copy and paste our trace here, because we're going to do another trace to make sure that because right now what we have is our player. We're going to trace to the right. We found a wall, but now we're going to trace like this, so we know that the wall has enough distance for us to actually run on it. Because if we just had a wall, you hit it here and then it ended, and you try to play an animation where he jumps and runs from here off of the wall, it's not going to look right because it's in the air. So yeah. So from here, we are going to add another pin to this plus, and this is going to use a forward vector from our return rotator on our little function here. And same thing, we're going to use a multiply here, which will be 150, but we don't want this anymore, so we're going to remove the pin. And we'll just add this in here. So from here, we're going to call our return node again. And the return value will be the return value of our trace, like so. Just going to add a rewrote node here to organize it. Now is when we need to connect all of this up. So for our wall location, this is going to be our impact point plus our impact normal multiplied by 90, like so, and I'll explain why we're doing this. So we're gonna have our little guy again. So if this is the wall, players here, we trace and we find this point, because later on we're gonna want to set our character to be next to the wall. So we're using the normal of the wall, which would look something like this, right? And so we're using this as a way to multiply off of the wall. So we're getting the wall location and using the normal to go away from the wall. And then later on, we'll set the location to here, so we have the animation sync up with the wall properly. And you can just drag this all the way over here. Add some reroute nodes to organize it. And now we need another function for our rotation. So let's go ahead and do that. So we're going to do find wall rotation. And in here, we're going to need 2 inputs. We're going to need a vector, which will be our impact normal. And then we're also going to need a float, which will be our directional multiplier again. And by default, I'm going to set this to 1. All right. So we're going to get our return node. And we are going to return a rotator. So this will be our return value. So in here, we are going to get our impact normal. So this right here. And then we are going to multiply it. And so we already have this. So this is the wall. And I found that we need to invert the normal for some reason so that the rotation can be calculated properly so that the player is facing this way from the forwards of the wall. So if this is the wall, we need to invert the normal so that you would rotate this way so we can be parallel to the wall. So we're going to do a float. We're going to do -1. And then this is here where we're going to get our directional multiplier. Like so. And then we're going to do a cross product with our actor rotation. And then we are going to get up vector. And do like that. And so basically what's happening is this cross is getting these two vectors and finding a vector that will be aligned with the wall so that then we can do rotation from X vector. And this will just go into our function. And I'm just going to organize this, and this will also be a PR function. Now back in our trace for traversable wall, we're going to do find wall rotation and plug this in. And so now we need our impact normal, which will be our impact normal here. Add some reroute nodes to organize it. And then our directional multiplier, get directional multiplier, which in this case is from here. And that's all we need for this function. Now we are going to do find. So now we're going to do find traversable wall. And in here, we're going to drag in our trace for traversable wall. And we're going to have 2 of these. And this will be our right wall. So our directional multiplier will be 1. This will be our left. So we're going to do -1. And we're going to create some local variables with our outputs here. So this will be found right wall. This will be our right wall location. This will be our right wall rotation. There we go. Plug this into here. And same thing for our left. Found left wall. Left wall location. And nope. Local. Left wall rotation. There we go. And now what we're going to do is we're going to get our found right wall and our found left wall local variables. And we are going to use a Boolean node. Plug both of these in. And this result will be the condition of a branch. And off of false, this is now where we're going to have our first actual variable, which will be found wall. And so what's happening here is if we haven't found a left or a right wall, then we haven't found a wall at all. So we're going to set this to false. Now from true, we're going to do another branch. And we are going to get both of our found variables, local variables, and we're going to do an AND boolean. So this will be a condition to our branch. So this is saying, did we find both a left and a right wall? And so this will be, no, we did not find both of them. We did find both of them off of true. So we'll do false first. So we're going to make a wall location variable. So this is a real variable, so a vector. And then a wall rotation variable, which is a rotator. And here we are going to set the wall location and the wall rotation. And just organize this. And what we're going to do is we're going to use select nodes so that we can select the location and rotation based off of our booleans. So I'm going to be doing everything basically with the context if we found the right wall. So found right wall, true, right wall location, false, then it would obviously be the left wall location. And same thing for our rotation, except now we're going to use our rotation variables. And obviously plug these in here, like so. And we are also going to need different animations based on the wall. So we're going to use another select node with the index being found right wall. And here is where we would set up our animation montages. So in here, I already have these. So you just right click on them, create anim montage. And in here, I basically just timed the animation start and end so that it would look good. So the full animation kind of had him starting on the ground a bit more. I didn't want that, so I just put it to 0.1. And then I made it end when it looks like they're mostly in the air. And I just did a 0.15 blend time for the in and 0.3 for the out. Really depends on what animation you're using. And this is the same thing for the right wall. And I also am using root motion animations, so I made sure to enable that here. Awesome. So we are going to need another variable, wall animation. This will be anim montage. And we're going to set this here and plug this into our select. So if we found a right wall, we're going to use our right wall animation montage. And our left animation montage if we did not find the right wall. And by the way, just in case you're not aware, this is using the default group, default slot. And in your animation blueprints, you would want to make sure that you have a default slot here or whatever slot you're playing these animations on. If you're using the third person template, you don't have to worry about that at all. It's already set up here by default. Awesome. So that's pretty much it for the false route for now. So let's move on to the true route. So we did find a left and a right wall. So now we want to decide which one's closest to us and pick that one. So the way we're going to do that is we're going to get our actor location and our left wall location, and we want the same thing but for our right wall as well. And here we're going to do distance vector. So we're basically checking what's the distance from our actor location to our left wall and our distance to the actor and our right wall. So here I'm going to be checking if the left wall is less than the right wall. So here we would be doing another select, and you can just actually copy all of these because we need to set all of these again anyways. And in our true, we bring it over like this. So if the distance to the left wall is less than the distance to the right wall, that would mean we're closer to the left wall. So if we put this into here, right? If we were closer to the left wall, and that's true, then it would pick the right wall location. We don't want that. So we're gonna do a not boolean. And yeah, there we go. And we would use, and we would use this for the index on all of these select nodes. Like so. Awesome. And now all of this would lead to setting our found wall. And I'm just going to use our found left and right wall local variables and do or boolean. And you may be thinking, why do we need to do this again if we're going off of here where we've already said, oh, both of them are set, so why would it be or? Well, the reason is because if both of these are not true off of false, we would be able to go from here all the way to here. So it's just making sure that we're accounting for both of these pathways just so that there's no issues. And I'm just going to organize this. Compile, save. And yeah, that's pretty much it for these functions. And for my case, I'm just going to use event tick to do this trace. If you want to save on performance, you could use a timer that's looping at a certain rate, or you could do it on the actual input, whatever. I'm pretty sure either of those would work the exact same. So here we're going to do find traversable wall. Cool. And next, down here on our jump input, just going to expand this so I have a little bit more space. Here, we're going to want to check, did we find a wall? We did not find a wall. So we're just going to jump normally. True. So this is where we want to create our new event. And this will be custom event, wall jump. And here is where we would call that. Awesome. So here, I want it so that you can only wall jump from the ground. So I'm going to get our character movement and I'm going to get our movement mode. And I'm going to switch on E movement mode. So when you go off of here and do switch, we're basically switching on the value of this enum, which directly corresponds to the movement mode. So if you're on the ground, this would say walking. If you're in the air, it would say falling. And so on. So here I only want to, and I'm actually going to expand all of this because we are going to need a lot more room. So there we go. So I only want to be able to wall jump if I'm on the ground. So to do that, you would only do your logic from the walking. Next, we're going to go into a branch. And I like things tidy and aligned with the grid. So I'm just going to use a reroute, place the branch up here. And we are going to create a new boolean, which will be wall jumping. And I'm just going to make it so that we can only wall jump if we're not wall jumping. So are we wall jumping? No. So then true. So then we would say, now we are wall jumping. So this is basically functioning like a gate. Now we're going to do set actor location and rotation. And we're going to use our wall location and rotation variables. Next, we are going to jump. And the reason why we're doing this again, even though we already made a specification here, is because I found that if we don't call some kind of way of adding velocity to the character, the root motion would just keep you here, like down on the floor. It wasn't like this in the game animation sample, but yeah, that's the reason why I'm calling this here again, is because it'll give us some vertical movement. Alright, next we're going to do a play montage. And we are specifically using a play montage instead of play and a montage because we have these outputs here. So from our typical execution pin here, we are going to go based on the movement mode again. And we are going to set our gravity scale. And this will be on walking. And I'm going to set this to 0.6. And the reason I'm doing this is just so I found that I needed to lower the gravity for when they're going up so the root motion can do its thing and it work properly. May not be necessary for you, but it's just what I did. And next we're going to use on blend out, so basically when the animation is finished. So we're going to set the gravity scale back to default. For the third person template, that's 1.75. So that's what I'm going to use here. You can use whatever value that is for you. And then I'm going to set wall jumping to false. And then here, I'd like the character to bounce, or not bounce, but go forward a little bit when they end the jump. So to do that, I'm just going to do get actor forward vector. And I'm going to multiply this with a float. And I'd like them to go 800 forward. And then I'm going to break this vector. And I'm going to launch the character. So I'll just plug this in here. The reason I broke the vector is just in any case that there's some kind of Z here, I want to be able to control the Z myself. So that's why I'm just connecting these separately. So the launch Z will be 450. And I'm going to override the X and Y and Z. And that's pretty much it. So if we go into game now, I want to make sure that my character is set properly on the game mode because I changed it. So now if we go into game, we can see these two sphere traces happening. And if we go up to a wall, that one got set to true, so then it created that one. And if we press spacebar, it did not work. Okay, I know why it didn't work. It's because in our find traversable wall, on our select, oh no, we did put the animations here. Oh, right. It was actually here on our montage to play. We didn't add our wall animation here. Oopsies. Alright, so now if we go in game, and we have found a wall, there we go. We are now going to wall jump, like so. And now as you can see, if we find the closest wall, that's the wall we're going to go to. There we go. Awesome. Thanks for watching, that's all. This video was made possible thanks to my patrons. I have a Discord server for fellow ambitious and experienced artists and game developers if you need assistance with your projects or just looking to hang out. Bye bye.